Hello everybody, welcome to this AWS virtual workshop on getting started with Amazon DynamoDB. This is episode number 2, and we are continuing to build upon what we learned last week. Today we'll talk about querying and managing DynamoDB tables using Python. My name is Si-Young Ri, and I'm an education manager on the AWS databases team. And I'm here with Pete Naylor. I'll hand it off to Pete to do his introduction and then continue with the course.
Hey everybody, thanks for joining again. I am a specialist solution architect at AWS for the Amazon DynamoDB team. I've been with AWS about 3.5 years. Really fell in love with DynamoDB as a service. I'm excited to be sharing some of that excitement with you through the workshop. Please do reach out with any questions you have, and we'll try to answer as many as we can. So as we mentioned, this is a series of workshop sessions running every Friday. There'll be 5 of them that we have planned. Last week we worked primarily on the Dynamo Db Console, and this week we're going to use Python to manage DynamoDB tables and to ingest some data and query that data. You can see here on the episode plan we have 3 more episodes that we're planning to run through in the coming weeks. But let's go ahead and get started with this week's. So let's talk first about accessing DynamoDB. We want to build some more automation and go beyond that console that we worked with last session. AWS offers a command line interface which can be installed on Windows, Mac, or Linux. It allows you to easily access your manage your AWS services and resources from your command shell. So you can see a few examples that I'm sharing here using the DynamoDB part of that AWS CLI. And I want to call out that we recently moved to a new version 2 of the CLI as default. And if you haven't upgraded, I'd highly recommend taking a look at that. You can see here some really pretty nice features of the CLI where you can use tab for automatic completion. And one of the things that I think is really cool about version 2 is we've extended on that, and you can now actually do tab completion for your DynamoDB table names. So the cool thing about this CLI is actually that you can build really pretty complete DynamoDB applications using simple shell scripts. So behind the CLI and all the use of DynamoDB is a low-level API, and this includes a control plane for actions like table creation, updates of the table, deletion, and also a data plane for all of the data operations you can use with your tables and indexes. So here we can see the list of those low-level APIs. We can put an item, get an item, update an item, delete an item. We can do some batch operations, so batching a number of different writes or batching some gets, some reads, and we can also query a collection of items. Last week we talked about a collection being a set of items that have the same partition key value but different sort key values, so that we can do more complex querying across that and place sort key conditions or sort key expressions on those queries. We also have a scan API, and interestingly, that's the only API that we have where you don't have to actually specify a partition key value. The scan API is the one API where you're going to read every item off of your table. So this is commonly used when you want to maybe copy everything out of your table into a file in S3. Maybe you want to, once a day, extract all of that information and feed it off to some kind of a data warehouse. Scan is really useful for that type of a situation. What we don't want to be doing is making a scan across all of our data just to get one record or a small number of records. It's not really an efficient approach. We really want to build in some indexes so that we can get exactly what we're looking for. So the last two data operations that are there are newer for DynamoDB. They allow us to actually wrap a number of different actions into a single atomic group. So with transact write items, we can now say we want to make these changes to these 10 different items, but we want them all to either succeed or fail. So we can build that as more of a transactional workflow. Same thing for transact get items, where we can go and get a number of different items and be sure that it's a consistent point-in-time view of those items all together. So those are really pretty nice new features for advanced use cases. I think we'll get to some of those a little bit later in the workshop series. In any case, as you can see, as a user, you're going to connect to the cloud. You're going to connect to a HTTP, or actually an HTTPS by default, endpoint that we make available in each AWS region. And as you get to know DynamoDB better, you're going to come to know these various data plane APIs quite well. You'll recognize them as we actually work through the workshop also. So to make use of those APIs easier and more natural for developers, we offer support for them within the software development kit for many popular languages, including Java, .NET, Node, PHP, and the language we're going to work with in today's workshop, which is Python. The AWS SDK for Python is called Boto 3. All right, so let's talk about actually going through this workshop, and hopefully you will all follow along with me. Please do give feedback in the chat so that we can see how well we're doing on timing. Let us know if we need to slow down or if we can speed up. So we're going to start off with our management console here. The first thing you'll need to do is you'll need an AWS account. And that could be just a free tier account. Running through this example really shouldn't cost very much at all, and we'll clean up at the end to make sure we're not going to leave any resources sitting around. But here we have the AWS Management Console. The example that we're going to go through is an online bookstore application. So your bookstore has a large inventory of books that are stored in your warehouse to be sold to customers, and the application has to show users the books that are available for sale, as well as some basic information about the book, such as its author. And the application needs to be able to retrieve a specific book by its title and author so that a user can drill in for more detail when looking at a book. Furthermore, your application needs to allow users to browse all the books in a particular category, such as history or biographies, to allow them to discover books that they might be interested in. And finally, you might want to carry different formats of a book. So you might have a hardcover, a paperback, or an audio book. So your application should store those formats that you have in stock for a book with a mapping to the item number that's in your inventory system. Your application should allow these formats to be updated over time, as you may add or remove formats for a book. So let's start off by talking about the environment we're going to use in this workshop. It's actually a fully online cloud-based IDE called AWS Cloud9. So the first thing we're going to do is create that environment, and we're going to move down to the Cloud9 part of the console. You can just search for that and click on Cloud9. All right, so here we are in the Cloud9 console. As I don't have any existing Cloud9 environments, it's going to give me this option right here in the beginning banner to create an environment. So that's what I'm going to go ahead and do. Choose Create Environment. And I'm going to call this Bookstore. Maybe I'll call this Workshop Session 2. So I'll pause just for a moment there to give people time to maybe catch up. Feel free to enter any name that you prefer in here. Description is optional. When you're ready, we will go ahead and click the next step button. And we can just choose to go with all of the defaults here. What's actually going to happen is that Cloud9 will spin up a small EC2 instance for you that you'll then be able to use to test some of this functionality. We'll be running our Python scripts there. So all of the defaults are actually fine. You can see here, although we're going to do a cleanup at the end here, one of the nice things I think about Cloud9 is that when you're not using it, it will actually pause itself. It will automatically hibernate if you haven't been using it for 30 minutes. That seems like a nice default. I'm going to go ahead and click the next step. We get to just review and confirm all of our options. This all looks great to me. So I'm going to go ahead and click Create Environment. So this is going to take just a little bit of time for that environment to be provisioned and prepared for you. Pause here, and I assume everybody else is also spinning up their Cloud9 environments. Seong, did we have any questions or?
Yeah, I've been replying to some of them either publicly or privately based on how frequently they were asked. And I also assigned to you 2 questions that would be great if you could help answer.
Okay, so it looks like we have a question here asking whether we can query in 2 tables. And the answer to that is no. That would require two separate queries. One thing to think about there is the ability, because we have schema flexibility, to, rather than using 2 tables, maybe in the data model there's a way to denormalize and actually build that into a single table. And you could also, whether that be part of a collection or not, in that way we potentially could query across that single table and get multiple different types of entities that are returned. So another question here is from Mike asking about Boto 3 in a Python Lambda function. How do we make sure not to incur the connection overhead on each invocation? The connection could be established in init, but then it could go stale. And so, I mean, that's I won't spend a lot of time digging in on this because I want to move ahead with the workshop. But yeah, in a Lambda function, one of the things, because we're using this HTTPS connection, is that each time we open a new connection over the network, we have to authenticate and also make sure that that TLS or SSL negotiation succeeds. So we have the secure pipe that we need to do these things. One thing that can happen with Lambda functions, because they are spun up as needed or invoked as needed, it can take a little bit of time to open that initial connection. So one of the best practice recommendations is to make sure that actually setting up that session happens outside of the main handler loop. And Mike already mentioned that. That's definitely a best practice. I'm glad we got to mention that one. If it's outside or outside of that, if the sessions are going stale, unfortunately it is going to take time to just set those up. One thing that you could do potentially, I believe that Lambda has recently added a feature where you can essentially kind of pre-provision and hold open a number of different Lambda functions. You could perhaps have a timed request, just something that keeps that session active. Maybe make a small request once a second. Okay, so I'm going to go back to my screen share here. Here it is. And we can see that our Cloud9 environment is now ready to go. How's everybody doing? Does anybody need more time? All right, I'm gonna assume that everybody is ready to go and move forward. So we have our Cloud9 environment, and we can see that over here we have on like a file listing window on the left side of the screen. We also have the main banner here that this will actually be where we could edit our code if we want to. And finally, down the bottom we have an actual shell that we can use. So this is what we're going to use to run through the workshop today. One of the first things that we're going to do is we're going to download the various Python scripts that we're going to be working with. So I'm going to type this in here. We're going to use curl and give these options. For the moment, I'm just going to see if I can zoom in a little bit more. Maybe not. Okay, so hopefully you can see this on my screen well. So this command is basically going to go out to S3, grab a file that includes all of our Python scripts. It's going to download that and then extract it. I'll go ahead and do that. And there they are. Those will be our scripts. You can see that they've also populated the file listing window on the left. Maybe one thing I can do is paste that into the chat window. Let me give that a try. All right.
By the way, Pete, it looks like some people are having trouble trying to copy your exact command. Can you copy and paste the commands into the chat window, so people can just copy and paste?
Yep, that's exactly what I just did. If you have a look at the Q&A window, I think that should have shown up. Perfect. There it is. Okay, great. So what I'm going to do, we can see the list of files over here also in our shell window. Since we know that they're there, I'm just going to shrink this a little bit more if I can. All right. So the next thing we need to do is install the SDK, which is Boto 3. I'm going to go ahead and type sudo install Boto 3. So this is just installing that Boto 3 SDK for our Python environment, and I'll type that into the chat window also. So we can see here that it has made sure that we have all of the requirements installed. We have Boto 3 installed and ready to go. So the next thing we're going to do is insert and retrieve some data using Python scripts. I'm going to down here, and we're going to use a Python script called create table, and that's going to actually call the control plane create table API and create the table for us. I'm going to open that up, and hopefully everybody can follow along here. Essentially, this script is going to set up the Boto 3 client. It is going to then go out and it defines the table name as books. It creates the primary key schema. Just as we saw in the console last time, we do need to define that primary key. The rest of the schema is flexible, but we have to have that defined when we create our table. So as we scroll through here, we can see that we're going to create the table in provisioned throughput mode, and we're going to use one read capacity unit and one write capacity unit, which should be just fine for our purposes. And we're going to use our partition key as author, and our sort key will be the title of the book. We also have to define the data type for those. So here we can see that both the author and title attributes will be strings. In any case, so that was that's our script. We can go ahead and run that by just typing Python create table. Actually, a minute. All right. So here we can see that I invoked Python and gave it the create table script that we just took a look at. And it came back saying that the table was created successfully. So the next thing we're going to do is actually write some data into the table. We're going to load a few books and their details. In this case, we have another script. It's going to be insert items. And we can see that here. So again, we're going to create that DynamoDB session. We're going to name the table that we're going to work with is books, the table we just created. And here we can see we're actually going to use the batch write item API to write a number of items into the table in a single request. We see 5 different items that we've defined here. And in Boto 3, that's a batch writer call. Okay, so let's scroll up. We're going to run that and just insert our items. All right. So that seems to have succeeded. So let's check that we actually did insert those in our table now. The next thing we're going to do is actually make a get item call where we're going to retrieve just one of those items directly. Here's our get item script. Again, we're going to initiate this session. We're going to connect to DynamoDB. We're going to work with the table that's named books. Get item, we're going to have to specify the exact primary key that we're looking to retrieve. So we have to provide both the partition key and the sort key. In this case, our partition key, the author, is going to be John Grisham, and the title is The Rainmaker. So we're just going to retrieve that item and then print it out. Let's go ahead and run that script. Python get item.py. And there it is. So you can see it's really pretty easy to make use of this Python SDK. Even at the point of just using an API call to create a table, create a database, and make changes to that. Let me quickly go and look and see how is everybody doing, and do we have any questions that I can answer? Maybe not. Looks like perhaps all the questions are being answered.
I did assign a few to you, so take a look at the ones assigned to you, Pete.
Oh, I need to scroll down. A lot more happened than I realized. Okay. So we have a question here, how to update an attribute that is involved in a one-to-many or many-to-many relationship and make sure it's updated everywhere. So for example, an actor's relation to a movie, if I update an actor's name, how do I make sure it's updated in every movie the actor is in? So there's a couple of different ways to look at this. you could basically use a global secondary index to build that that many-to-many relationship. In fact, that's how we typically do it. One-to-one, we use a simple key value or partition key only table. One-to-many, we have partition key and sort key. And a many-to-many, we then build a global secondary index, which inverts those two attributes. So you can look at things another way and build those collections. In this particular example, if you have a single item that is basically used or referenced through many other items, you have a number of different approaches here. You could denormalize that. If you denormalize that, you're basically building for super high velocity reads. You want to be able to just retrieve the item and not make multiple requests. Another way to approach this would be to actually store that separately, and in this case you're going to need to actually make multiple requests and piece that together. So those are the options. Another, I guess, one further option would be to keep them kind of separate, not to fully denormalize, and then when, for example, if you change the actor's name, you might have a streams a change data capture on your DynamoDB table where you see that change was made, and then you asynchronously go back and update all of the other records. So again, that would favor being able to then be able to go and make a request of a movie, and while it wouldn't be immediately consistent, it would be eventually consistent across those records, and it would allow you to very scalably conduct your reads with a single request and get very low latency. Let me look down here. Any more questions? Why are we using both and not AWS CDK? Oh, Boto 3. This is really just, I guess this is a good point. Certainly if you want to be managing your infrastructure as code, you have CloudFormation, you have CDK, you have a lot of options there for actually creating the tables and managing those resources. Those are not going to be what you're going to use for the actual data plane activity. You're probably going to be writing that application code in perhaps Python, in which case you can use the Boto 3 SDK to do that. You're right. I mean, in most cases, people are going to use something like CloudFormation to manage the creation and deletion of tables and so forth. But this just demonstrated that you can actually make those control plane calls from your applications also, since it's all API driven. All right. Does anybody want to go slower, faster? Shall we keep moving? I'm going to go back to my example here. So we just retrieved that one item using getItem. Again, that's pretty much mapped directly back to those low-level APIs that DynamoDB supports. So now we're going to move on and think about actually using the query call and retrieving multiple items at the same with a single request. In this case, what we want to do is use this query items script. And we'll take a look at that because, again, it is going to open that session. It's going to use the table books, and it's going to use the query call. We're going to set a key condition expression where the key, so again, with a query, we have to specify which partition key we're looking at. It basically says, this is the collection of items I'm interested in, and then we're going to place a key condition expression on that sort key, which is the author. And in this case, we're going to say the author is equal to John Grisham. So I'll go ahead and run that query just by typing Python query items. Okay. And here we can see that as it says, the query has returned two items, two different books, both by John Grisham as the author. So hopefully that is all working for everybody else that's maybe following along also. So retrieving these multiple items in a single call with DynamoDB is a really common pattern. Um, and as I mentioned earlier, it's really around building these collections. A collection, in this case, in this example, we have a collection. It's collected by partition key choice of the author, and the title is what makes those items unique, because they do have to be unique. In this case, each of the items that are associated with that author's collection happen to have the same form. They're all books, but these could be other records. These could be metadata about the author. It could be, sales information, invoices. It could be the inventory. We don't have to have all of the same types of items in a collection. So what else can we do with these? We talked about, there were some questions about many-to-many relationships, or looking at the data a different way. And the way that we accomplish this is to use secondary indexes. Those allow us to support different access patterns for the same set of data, same table. And they give us flexibility for querying. So we have two different kinds of secondary indexes: global secondary indexes and local secondary indexes. We're going to use a global secondary index basically to use the category attribute of the items in our table. So now we'll be able to query from this new index and say, give me all of the books that have this particular category. So again, we're going to use a script here, which is going to update the table. We're going to add a secondary index. Same kind of thing happening here. We're going to initiate that DynamoDB client. We're going to try and add a index to our books table using update table. Update table is one of the control plane APIs that allows you to do things like adding indexes or deleting global secondary indexes. We also use it to change the amount of throughput capacity that we want for that table, and a number of other variables that we manage for a particular table. So here in our global secondary index, we do need to define what the name of our index will be, a lot like a base table itself, and we need to also provide the primary key, or the schema for the secondary index. We also have an option around projection. So this is where we're going to be able to choose which of the attributes we want to push into that secondary index. As an example here, if our query for finding all of the books that are in a particular category really just wanted the titles of the books, and really we didn't want any of the other details associated with that, we could just choose to project the attributes that we want, and that allows us to make much more efficient queries. Here again, we're going to set the provisioned throughput that we want for our global secondary index. We're just going to set it to 1 read capacity unit and 1 write capacity unit, same as we did for the base table. So let's go ahead and run that. So we have added our secondary index. And if this were a large table, even with a small table, creating a new table or creating an index takes a little time. It's not an instant result. But what we're going to do is within our next query that we're going to make, we're going to make use of that index. So let's take a look at that. This is the query with index script. Again, we're importing Boto 3. Going to create that connection using, and we're going to name the table books because that's the one we're going to work with. You can't immediately query that secondary index. As I said, particularly if you had a really big table full of data already, it takes some time for the service to actually build that index. In the meantime, you'll see the status if you go and take a look in the console, look at the status of that index. It will say perhaps that it's backfilling and it's working on creating that index for you. When it is complete and now the index is available, it switches to being in active status. So in this particular script, we're actually going to, although I don't expect building the secondary index on such a tiny table would take long, we do have a check in here that says, I'm just going to keep checking. If the index is not in active status yet, I'm going to keep looping around and trying every 5 seconds until it works. And then we're going to make, again, a query call. It's the same API that we're going to use for our secondary index as we would on the table. And this time we're going to add, not only is the table name books, but we're going to be looking at this particular secondary index called category index, the one that we just created. We're going to set a key condition expression. Again, we have to say, for our secondary index, our partition key that we chose was the category attribute, and our value for that we're going to choose is suspense. And in this case, we're not going to put any other requirements on that. So let's go ahead and make that query. This time we're going to query with index. And here we can see we got 3 books back, all of them that are in the suspense category. So adding a global secondary index allows us a different way to view our data. We have the other type of secondary index, which is called a local secondary index. Not as flexible as a global secondary index. You must use the same partition key, but you can use a different sort key. So that would allow you to maybe get your results back in a different sorting order. Okay, I'm going to switch back quickly and just see if we have any questions. Are people able to follow along? Has anybody had any trouble with using Cloud9 and getting those scripts or executing them? It looks like most people are doing okay. Great. All right, I'm going to have a quick look at some questions here. Okay, so the question here from Rodolfo asking about why did the 5 inserts work in a table that has 1 write request per second? So it's an interesting question. Firstly, when we make these calls, all of the SDKs actually have retries built in and exponential backoff and so forth. So if we have a table that is provisioned at 1 write capacity unit and we're inserting items at a 1 write capacity, 1 item per second rate, then if we try to insert faster than that, if we're doing it persistently, we can get what is called throttling, because we're trying to use more of our reads and writes than we're actually provisioned or paying for. One of the things that can become difficult about that is sometimes you make a burst of activity, like in this case where I had a table, I'm paying for 1 write request per second, but I haven't been doing that consistently or persistently. So one of the things that is built into the service is what's called Boast Capacity, and that will allow you to basically, over a 5-minute window, kind of like in a cellular phone data plan, you can carry over within that 5 minutes capacity that you haven't used. And so in this case, it returned really quickly and processed those all at the same time because we were able to make use of that burst capacity. If we didn't have any burst capacity left, what would have happened is we'd be able to make one call, and then the others that didn't succeed would be returned in a batch, and then we could choose to retry that and just insert the ones that were not processed on that one request. Question here, can we get the item in table format or in JSON? So it's always going to be returned by DynamoDB in what looks like a document or JSON document type of format. How you choose to present it or display it from there, from within your application, is entirely up to you. There's a lot of flexibility there. Within the CLI, there is some options on how you want to display that within the CLI I know about. So I would take a look at that if you're using the CLI. Otherwise, look at what options your SDK presents to you. How can we, this question here from Edwin asking about how to implement a full scan. What will happen with a scan is it's going to read every item in your table. And it's going to return up to 1 megabyte of data per scan request. And this really gets into another topic, which is pagination. This happens with query calls as well. If your request was going to return enough items that it was 10 megabytes, what's going to happen is you'll get the first 1 megabyte, and you'll get a token in the header of that response that tells you, here's the first section, there's more to come, and when you make your next scan request, please provide this token and we'll pick up from that point and move on. So you essentially, with a basic scan, you're going to make a series of requests if you have more than 1 megabyte of data, and you're going to receive page after page. Alternatively, we have support for what's called a parallel scan, where you might have 10 worker processes that are all going to work on scanning the table, and you make those requests. Again, they'll be paginated in up to 1 megabyte chunks, but you can have each of those worker processes basically scanning 1/10 of the overall table size. So I hope that answered the question. Do we have Python code to read from a .csv file in S3 to DynamoDB table? I don't have one that I can just share with you right now. I do think maybe on Twitter I've seen some folks talking about some code they've built to do exactly that. I would maybe go and have a search around on GitHub and see what's available out in the community. Question here, what is the case when response is really big? Does it require a special command to take care of memory usage? Not sure I really fully understand this question here, but perhaps this comes down to, again, that pagination, where we're going to retrieve up to 1 megabyte per query or scan request. And beyond that, we actually have to go to the next page. We make another scan or query request, and we give the token that we're provided as the starting point for picking up where we left off. Where can we see the table and structure we are using? I see the Python file for the create statement, but I want to see the table. Okay, yeah, it's a question here from Summer. One thing you could do, going back here, and I might take a break from the questions after this and go kind of see if we can close out on the demo. But one thing you could do would be to go and take a look in the DynamoDB console. So let me do that actually. we go take a look at our Dynamo Db Console, we'll be able to see the table that we've created. Here is our books table. This is getting back to maybe what we worked through a little bit last week. We can take a look at this and go look at the items. Here we can see that this is a scan and it's actually showing us all of the items in our table. We can also see some metrics on our DynamoDB table. Here you can see that we're consuming some of our provisioned write capacity and also consuming some of our reads, little tiny bumps here. There's a bunch of different really great CloudWatch metrics that we can work with on our DynamoDB tables. We can set alarms and manage the capacity and so forth. We can also go over here and see that global secondary index that we created called category index. Okay. Oops. Go back to Cloud 9. So that was our example of using secondary index. We built the secondary index and then queried it to be able to get a different view for the items in our table. The next thing we're going to work on is updating some items. We have a few different ways to update our item. We could actually use a put item call, which would just replace the existing item that has the same primary key, or we can use update item, and it will basically just make changes to particular attributes. So we don't have to go and read the item and see what all of the attributes are first. We can choose to just update particular attributes. In this case, we can imagine that maybe we've recently added an audiobook format for John Grisham's The Rainmaker book, and we want to update our table to reflect that change. So in this case, we're going to use this update item Python script. Very similar to all of the other scripts, of course, we're going to have to create our client and set a variable to say that we're actually going to be using the DynamoDB table that's called books. And we're going to use get item that we saw earlier to look at the book before we update that. Here again, because it's a get item call, we have to provide the complete primary key. This is a composite primary key table, so it has a partition key, which is the author, and a sort key, which is the title. So we can see we're going to look at the item, which is John Grisham's The Rainmaker. We're going to print out that item as it looks before the update. And next we're going to actually make the update. You can see that we're going to use the Boto 3 update item call. We're going to name the key that we have to specify which actual item we're going to be updating. And we're going to name some expression attribute names. So we basically have to decide which of the attributes that we're going to be updating and create variables or placeholders for those updated values. Here we're going to change some of those values. We're going to set the update expression. We're going to set the formats, the audiobook formats, to this particular ID value. And then after we've done that, we're going to use the get item API again to go look at the book, and we should be able to see that it is actually updated. So fairly simple script. We'll go ahead and run that now from Python. I wonder, I should check, are we still zoomed in? Yes, we are. Good. update item. Run that script. So here we can see, I'm going to actually, we can see the item before the update. The title is The Rainmaker. The formats say hardcover, paperback, and these are the actual inventory numbers perhaps for each of these book formats. And here's our author as John Grisham, category is suspense. After our update, you can see that it's the same title, same author. We've added the audiobook format and the inventory ID for that particular audiobook. So again, with update item, we don't have to read the item first to get all of the values. We're just going to add that particular format or update the value for that particular attribute. All right, so let me go back again, see if we have any questions I can answer. Siyoung, do you see, how is everybody doing on timing? Are folks following along and able to keep up? Any particular problems anybody's run into?
Pete, I did assign you a few of the questions that came in.
Got it. All right. Let me go find those. Okay, so there's a question here asking whether the query command is inefficient. What's the recommendation if I want to query for fields that are not in the primary index? So this is a choice you make, and really when you're building your data model, you want to model and store your data and have indexes for frequent requests, frequent access patterns. So if you have, for example, a collection of items, maybe, you know, for a particular author, you have 1,000 different books, and you know we're using the title as our sort key. If we want to be able to sort or to be able to filter within that particular collection based on some other attribute that's not part of the primary key, we can use a filter expression. But what I would say is you want to choose well when you're using a filter expression versus a sort key. If it's something that you're doing very often, if we set a sort key or a key condition expression that maybe brings back 50 of John Grisham's books, and then after that we want to apply this filter expression, and it actually kind of discards 95% of those and actually only returns 3 books to us, then we're actually going to, from DynamoDB's perspective, we're going to read all 50 from disk. We're going to pay for the read consumption across those, and we're really only interested in 3 of those records. So if that's something that, if we do that rarely, that's not a big problem. But if it's something that we're running thousands of times a second, it's a query pattern that we do very, very frequently, a better approach would be to index things differently, either index differently in the base table or create a secondary index so that we can query with a sort condition that's part of that sort key, or a key condition that's part of that sort key. When it comes to doing data models for this kind of DynamoDB solution, you really have to think about what are my query patterns, and which of the query patterns that I'm going to run most frequently. And then you build your data and you build your data models such that you're able to meet those needs very effectively and efficiently. Okay, scrolling down, looking for some more questions here. There's a question about whether you can use any item as a sort key when querying with your global secondary index. So I think probably what was meant here was, can you use any attribute as a sort key when querying with your global secondary index? So the answer is yes, you can create a secondary index on any of those attributes. There are some restrictions on the types of attribute data that you can use as part of the primary key. So for example, you can use strings, you can use numbers and so forth, but we also have some data types that support lists and sets and maps, and those are more complex fields. Those cannot be used as part of a primary key. So that's the one thing to be aware of in that regard. Scrolling down here some more. What is the impact on table read or write performance for having more than one global secondary index? And how should we adjust table reads and writes when adding a new global secondary index? Okay, yeah, this is a great question. So the impact on the table itself for read and write performance is there is no impact on the table when you create GSIs. So you know, you're with DynamoDB on your base table, you're going to set, I want this many read and write capacity units if you're in provisioned mode, and we're going to provide that to you on the base table regardless of what the GSI is doing or how many GSIs you have. So there's no impact in terms of latency or performance on the base table when you add global secondary indexes. Having said that, adding, you know, global secondary indexes is just like having another table. So there's storage cost involved in that. You need to provision some read and write capacity on the global secondary index also. So when you're thinking about adding a global secondary index to optimize or make a particular query pattern more efficient, recognize that if it's a pattern that or an access pattern you're only going to use once a week or, you know, once a month, the cost of having a global secondary index to support that most efficiently may not be worth it. It may be better just to do a scan once a week or to use some other method to get that particular view of your data. One thing I will say is that the reads in your base table won't be affected by a global secondary index. The global secondary index, though, we do promise to make it consistent. It's eventually consistent, but we do promise to make it consistent with the base table. So when you're writing into the base table, if you create a global secondary index which doesn't have enough write capacity configured to keep up with the writes into the base table, then eventually those writes will push back against the writes into the base table. We call this back pressure, and it's mostly to stop customers from getting into a situation where their secondary index can never catch up and never become consistent. So as a guideline, what I would say is, you know, for a brand new global secondary index, that index, depending on whether it's a sparse index, which attributes you're projecting, a number of different things, it's going to need anywhere between 0 times and 2 times the write capacity of your base table. So if you have an existing base table that already has a lot of data in it, and you're going to be creating a new GSI on that, I would say, you know, one approach would be to just create the global secondary index with at least twice as much write capacity, just to be sure that it can keep up, and you can dial that back as time goes on. Okay, let's see, one more question. Is there a queryable catalog where all table definitions can be found? So I'm not sure I'm entirely understanding this question, unfortunately, but there is an API call where you can call DynamoDB and say list tables, and it will give you a lot of information back about those tables. There's also another API in the control plane that's called describe table, which will give you a lot of details about each of those tables, including the primary key and the throughput that is provisioned and so forth. Okay, I'm going to take a break from the questions here, if that's okay, and go back, and we'll just go back to our demo here. We really don't have too much left to do on this with this workshop, but one of the things I do want to make sure of is that we do some cleanup. Don't really want to leave these resources sitting around. So in this case, we're going to use another one of the APIs, a control plane API called delete table. And we can see that up here. Again, it's going to be very, very similar to a lot of what we've already seen in the other Python scripts. We're going to set up a client with Boto 3. We're going to be working with the table named books, and we're going to issue a delete table call. So let's go ahead and try that. Python delete table. So one of the things to note about that is that it will also delete the secondary index that we had created. We can see that the table has been deleted successfully. So that's great. The only other thing that we need to do is to clean up that Cloud9 environment. I'm going to assume that we don't need it anymore. So we're going to go to the Cloud9 console. Here we can see our list of environments. There is Bookstore, the one that I created for this workshop. And I'm going to choose this Bookstore. And we can go ahead and delete that. It's actually going to ask me to confirm that, just to make sure I'm not accidentally getting rid of something I really wanted to keep. And I'll go ahead and click delete. All right. So let's, we've finished our cleanup. Let's maybe take some more questions for a little bit. Young, did you have any in particular that you wanted to touch on, or I'll just keep working through the list here?
Yeah, there was a recent one from Martin asking, in your update example, the expression attribute placeholder follows a sharp and colon syntax. Is that an arbitrary choice or a particular syntactical requirement?
Maybe I should go back and find that particular example. There is a particular format that we choose for those variables, and that's used throughout all of the different APIs. It's not arbitrary. How can you review what an index is in the console? When you go to the console, it looks like I can create, new, and delete, but if I have 15 or 20, how can I review which one is without tracking down the Python file? All right, so in the console, you can, when you go and look at your view of tables, one of the tabs that you have there is the indexes that are all listed, and I believe you can click on those indexes and it should show you, for example, which attributes you chose for the partition key, and optionally the sort key. I think I've answered that question. Here's a question from Vincent asking about will the table or index get fragmented over time due to high DML transactions and has to be rebuilt? So the answer to that is no. What will happen is DynamoDB will do all of the horizontal scaling for you automatically in the background. So whether that's because the overall size of your data set, the overall size of your table is growing, and we will manage that for you. We basically break that into what we call partitions, kind of like shards, I guess, a number of different storage nodes on the back end. So we then redistribute your data across those, and that all happens automatically. The same thing is true for your throughput.
By the way, there was a comment that came in.
Sorry, what was that?
Sorry, go ahead, Pete.
Yeah, so the same thing happens with your throughput. If you need to be able to read and write across your table at a higher velocity, DynamoDB will split those partitions in the background, and you'll be able to support the throughput that you need in that way. So those partitions never remerge over time, and one of the worries that people sometimes have is they wonder, does that mean that the throughput that I had provisioned, or my capacity needs are now becoming more dilute? DynamoDB doesn't work that way today. Basically, any one of your items in your table will be able to serve up to 3,000 strongly consistent reads per second or 1,000 writes per second. And that's true no matter how we've distributed the items on the back end. So this is really, to me, one of the things that is really quite unique about DynamoDB. We have this ability to scale very, very elastically. We could have a table that is supporting 100 requests per day, and then because of some event we want to scale that out and be able to support 1,000,000 requests per second. DynamoDB will be able to split all of that data across as many storage nodes as we need. We'll be able to serve that for you. You can run at that level for an hour or a few hours as long as your event is running, and after the event you can descale. So while we still have all of your data spread across many different storage nodes on the back end, and you could scale to that level again very quickly, you can reduce your provisioned capacity and again be back to paying for only your 100 requests a week. So that's a pretty amazing kind of elasticity in my experience. Certainly, it's nothing like I'm used to from earlier days of my career when we were having to install operating systems on servers and get them racked and do all of that kind of thing. That scaling elasticity is quite magical, I think. Question here, is there a type of item level locking or some way to address competing read-write or write-write requests? Yeah, so this is an interesting topic. One of the things that we can do at a per item level is we can do what's called a conditional write, and essentially that's optimistic locking. It's a multi-version concurrency control. So if we have a particular item that we don't want to be seeing updates from multiple different application threads at the same time, we can make an update to that item but set a condition on it. So oftentimes we'll build in an attribute that's a version attribute. So the pattern would be we're going to make a kind of a read, mutate, and then conditional update pattern. Our application would go out, it would look at, it would get item, it would see the existing view of the item. In the application, then we're going to mutate that. We're going to make some changes. We might change some values or add some attributes, whatever we want to do. When we go back to then write our updated view or our updated item, we're going to put a condition on that says, I only want you to write over this item if the version number is the same as what I think it should be. If we see that the version number has changed, then some other thread actually updated that item, and what we need to do is read the latest version of that item and try our mutation again, or otherwise handle that situation. But this is a very, very common pattern that gives us the ability to have multi-threaded consistency over updates against a single item. It gives us isolation. Building on that further, we can also use the transactional APIs that are newer, which allow us to do that across multiple items in a singular atomic update. We can do all succeed or all fail. One more question. Can I use my own custom IDE to run these scripts, and how I can connect to the dev endpoint? Yeah, absolutely. If you go grab that URL, you're welcome to download that set of scripts and work with those in your own shell against your own account, and definitely I'd encourage you to play around with those, learn some more about DynamoDB. Using the Cloud9 IDE is just a really nice, convenient way for us to run the workshop. And I think at this point, maybe I can do one or two more quick questions, but we should close it out then perhaps. We're running out of time. Does the Python Boto 3 call log the error or success details anywhere? No, it doesn't necessarily, unless we choose to log that within our application, and that would definitely be recommended. If this were a real application, you would want to log the results of that based on the kinds of questions you might have about that activity. Can I do rollback inserts to a certain point in time? No, I think there's not any kind of a real built-in functionality around that. What you could do is you could build what we call versioning into DynamoDB collections. So if you want to, and there's actually a really good page about this in the documentation that gives an example of doing this. You would basically create a collection for a single item. You would actually keep a row. You would keep an item with its own specific version number, and in doing that, then you can query and say, I want to get the latest version, or I want to get the version as of this date, or give me the last 3 versions. And certainly you could extend on that to actually roll back. You would basically update the pointer to the current version so that it went to that prior view of your item. Okay, I think.
So I think that was all we could cover today. There were some comments on if this program was recorded. It does not. We are live broadcasting from Seattle in our homes. And the reason we couldn't answer all of the questions were because there were hundreds of them from hundreds of you. So we tried our best to answer the most as we could. Some we were answering privately through chat, and some I posted publicly, the ones that were more common. And then also some I assigned to Pete so that he could reply them through voice. And so we'll do our best to answer questions through these series. Next week, we'll be going a bit deeper. We'll be building upon the things that we learned last week and this week. And starting next week, we'll be actually data modeling a table based on a gaming application. And so we'll be using more real-world scenarios in how to model your table. And so please tune in next week at the same time. And then we'll be sure to answer more questions or more deeper questions that you may have next week as well.
All right. Great. Thanks, everybody, for joining. We'll talk to you next time.
Thanks, everyone.
Bye-bye.
Take care.